Okay, in this video we're going to take a look at writing the equation of an ellipse given some information about it. So in essence it's going to really use what the values of A, B, and C represent in our equations for not only our ellipse but our focal points as well. So example 3, write the equation of an ellipse, part A here. Write the equation of an ellipse with vertices at 10, 0, and negative 4, 0, and foci at 3 plus or minus 2 radical 6, comma 0. Now, the problems in this video are going to, it's going to be very beneficial to get a visualization of what's going on, whether you use a Desmos or graph paper or whatever. So what I'm going to start with is I'm actually going to plot these two vertices, 10, 0 and negative 4, 0. So 10, 0, and we want to graph also negative 4, 0. And I'll make them the same color, although it's not really important. All right, so let me just zoom out a little bit. So here's my, and again, this will be my first vertex, and this one will be my second vertex. All right, now, to get the equation, we're going to need to know the center of our ellipse, and the center of our ellipse can be found by finding the midpoint of our vertices. So if we find the midpoint of 10, 0, and negative 4, 0, what we're going to get for our center is 3, 0. So take the average of the x's, take the average of the y's, and you'll have your center. So let's go ahead and mark that down, 3, 0, and we'll label that, didn't want to do that, 3, 0, and we're going to label that the center. There we go. Okay, so for our equation, we have the center. We also need the value of a squared and b squared. We're going to write the standard form, by the way. And the value of a is the distance from your center to any one of your vertices. So if we look at the distance between 3, 0 to 10, 0, we'd have to count over 7 spaces to get that from the center to this vertex. We'd also have to count 7 spaces to the left to get to our other vertex. So our value of a could be either plus or minus 7, really doesn't matter, positive versus negative. So a squared then is going to be 49. All right. So that helps us with that. Now we need the value of b squared. Well, to get the value of b squared, we're going to have to use our focus points here, our foci. So we have 3 plus or minus 2 square root of 6 and 0. So let's actually we'll type in one of those, 3 plus 2 square root of 6, and then 0. Oops, being a little bit non-responsive. And we'll label that a focus point F. Okay, so let's just zoom in for a sec here. And here's our center. Here's our focus point. Our center is at 3, 0. Our focus point is at 3 plus 2 square root of 6, 0. Well, in our foci equation, c squared equals a squared minus b squared, c represents the distance from the center to a focus point. And if we're starting at 3, 0, and our focus point is at 3 plus or minus, in this case, 3 plus 2 square root of 6, 0, then what we had to add to our center to get this focus point is this 2 square root of 6. Likewise, if we would have subtracted it, it would have been going to the left, going the other way. So our value of c, the distance from our center to our focus point, is this 2 square root of 6. So it looks really scary in this example, but our value of c is plus or minus 2 square root of 6. When we square that, 2 square root of 6 times 2 square root of 6 is 4 times 6, which gives us c squared is 24. And now that we have our c squared and a squared, we can find b squared by using the equation for the foci. So c squared equals a squared minus b squared. We have 24 equals 49 minus b squared. Subtract 49 from both sides, we get negative b squared equals negative 25. So b squared is 25. Now, because we're finding the equation, we don't need to take the square root of both sides. So last up is the fact that our vertices are to the left and right of our center, which means our ellipse is going to be wider than it is taller. So our value of a squared should go below the x in our equation. So we have the center at 3, 0, a squared is 49, b squared is 25, and our ellipse is wider because the vertices are to the left and right of our center. Same with our foci. So our equation then is x minus 3 in parentheses squared over 49 plus y minus 0 squared, or just y squared, over 25 equals 1. All right, part B, we have vertices at negative 6, 2, and negative 6, negative 22, and covertices at negative 5, negative 10, and negative 7, negative 10. So covertices, we didn't really talk about them too much, but we did mention them in the very first video. They are on the minor axis, which is perpendicular to the major axis. The major axis contains the vertices. But let's go ahead and plot these points. Just to get a visualization of what's going on. Again, very strong. I very strongly recommend you graph as much as you can. So we have negative 6, 2 for one of our vertices, and we have negative 6, negative 22 for the other. So we'll label this V1, and we'll label this V2. We don't need a V1 and V2. We just label them V. But let me put them both at blue here. All right, so let's zoom out a bit. Okay, so this time, all right, just enough there. This time our vertices are vertical, so this ellipse is going to be taller than it is wide. We still want to find the center, which is the midpoint of these vertices. So take the average of the x's and take the average of the y's, and our center is going to be at negative 6, negative 10. So let's go ahead and negative 6, negative 10. And that is our center, so we don't need a label for it. All right, so we have our center, which means we can find the value of a. 1, 2, 3, 4, 5, 6. So in this case, a is going to equal oh, these are counting by twos. That's why. Okay, something I thought something was really wrong there for a second. Yeah, so make sure if I'm counting the blocks, that each block represents a length of 1. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we could also get that by finding the distance between the center and vertex. So a is 12, which makes a squared equals 144. Now, covertices, the distance from your center to your covertices, each one of them is going to be b. So negative 5, negative 10 and we can, if we want, plot the other one, but the value of b is going to be the distance from this center to this covertex, and in this case it's a length of 1. So b is equal to 1, which makes b squared equal to 1, which now we have everything we need. So we have, since the ellipse is tall, since our ellipse is going to be tall, we actually have the a squared below the y. So the b squared is going to go below the x. So we have x minus a negative 6, which is x plus 6, in parentheses squared. We can put it over 1 if we like. Plus y minus a negative 10 becomes y plus 10 in parentheses squared, all over 144, equals 1. All right, finally, part C, we have center is at 0, 2, vertex is at negative 12, 2, and focus point is at 6 square root of 3, 2. So let's go ahead and, so I could just change the center here, actually. So center's at 0, 2. This will be at negative, or this would be at 0, 2. This will be negative 12, 2. So changing this. And then we're not using this anymore, so let's see what we have. So here's our vertex. Here's our center, so I'll just label that C for center. In fact, I don't even need the V anymore. And then my focus point is at 6 square root of 3, 2. So we have a focus point at 6 square root of 3, and then 2. Which is actually going to be over here. Now, again, we do have another focus point on the other side of the center. However, let's start by finding the value of a, which is the distance from the center to the vertex here. In this case, we're going to have a length of 12. So for this one, we have a is plus or minus 12 going either direction, which makes a squared equal to 144. And we also have our distance from our center to our focus point. And the distance from our center is at 0, 2 to our focus point, 6 square root of 3, 2, is this length is 6 square root of 3. So the value of c is 6 square root of 3. Again, you don't have to worry about the plus or minus. When we square that, we get 6 square root of 3 times 6 square root of 3 is 36 times 3, which is 108. So c squared is 108. Now, just like in example 3a, we want to find the value of b squared. So we're going to use the relationship that c squared equals a squared minus b squared. We have 108 equals 144 minus b squared. Subtract 144 from both sides. We get negative 36 equals negative b squared, which makes b squared equal to 36. Also, because our focus point as well as our vertex are left and right of our center, this ellipse is going to be wide. So we have everything we need. Because it's wide, the 144 is going to go below the x. So we have x squared over 144. You can do x minus 0 squared if you like. Plus y minus 2 in parentheses squared over 36 equals 1. All right, that about does it for this video. Thanks for watching.